Up to this point, we have constructed two foundational ingredients, a collection of possible states, and a distinguishability relation between them. But although structure now exists, that structure is still static. In the current framework, states exist and differences exist, but there is still no change, no ordering, no before and after. A deeper question now appears. How can one state transition into another state? To solve this problem, we introduce a new primitive, the update operator. The symbol U comes from the word update. It represents transformation, change, state transition. The expression means U takes one state from S and transforms it into another state inside the same state space. This gives the full update relation. The next state emerges from applying U to the current state. The symbol S sub t represents a state in an ordered sequence, and S sub t plus 1 represents the next state. But this is extremely important. At this stage, we still have not introduced physical time. We are not assuming time. We are only constructing ordered transformation. The update operator creates sequence. One state becomes another, then another, then another. The arrow does not yet mean time. It means an update operation has occurred. The sequence now creates ordering. There is now, before, and after. This is the critical result. Time is not introduced as a primitive. Time emerges from ordered updates. The distinguishability between a state and its update is always non-negative. But for real physical change to occur, the difference must become positive. If the difference is zero, then nothing has changed. A physical change exists only when distinguishability exists between successive states. The ordered update chain now produces temporal ordering. S0 becomes earlier. S1 becomes later. Time is not fundamental. Time is the ordering of updates. Some updates are reversible. If the inverse update exists, then the previous state can be recovered. In a reversible system, information is preserved. The past can be reconstructed. But irreversible systems behave differently. Multiple previous states collapse into the same resulting state. When multiple histories lead to the same result, the original past can no longer be uniquely recovered. This creates the arrow of time. Because the system cannot fully return backward, we can now define the magnitude of change. Sigma of S measures how much distinguishability is created through updating. Small sigma represents small structural change. Large sigma represents major transformation. We now arrive at the formal definition of time. Time is the ordered collection of updated states. Time is not inserted into the framework. Time is generated. Time is built from ordered transformation. This reinterpretation affects several fundamental areas of physics: relativity, thermodynamics, quantum decoherence. But one final problem still remains. If updates always occur, then why do some structures survive while others disappear? This forces us to introduce the third primitive, selection. We have now constructed the update operator, the emergence of temporal ordering, the difference between reversible and irreversible transformation, and the origin of the arrow of time. Reality emerges not only from difference, but from continuously evolving difference. In the next lesson, we will introduce the selection operator. We will ask, why do some structures persist while others vanish? Join us for Lesson 5.